Hello everyone and welcome back. Let's start with the reliability and correlation today. As you can see, the data is already entered for compound psychological capital. Why I am using this scale? Because it has 4 subscales, 4 dimensions. So basically we are going to run the reliability for all the subscales and for overall scale as well. So you have to go for analyze, scale, reliability analysis. And now you need to put the item numbers that are in a single subscale. Let's see, if you go towards the article or towards the main scale, you will observe that there are 12 items. Let me show you over here. Now these are the items. Item number 1, 2 and 3, they fall in hope. Item number 4, 5 and 6, they fall in self-efficacy. Item number 7, 8 and 9, they fall in resilience. And item number 10, 11 and 12, they fall in optimism. Now the first line is the German language, the second line is the English one, as you can see over here. So all I have to do is I have to label the scales as hope, self-efficacy, resilience and optimism. What I'm going to do is go back to the SPSS, select my 3 items, first 3 items, name it as hope. It's already as model is already alpha. Alpha is known as Cronbach Alpha, and Cronbach Alpha is the most common reliability analysis for your scale variables. You just go for the statistics, click on the item, on the scale if item deleted, enter item correlations, and you have to continue. Or if you want, you can also go for the means and other descriptors as well. Go continue and click OK. And you will be having a detailed analysis. First is your summary, how many cases were there, what was the sample size. As you can see, n is the sample size and the percentage is 100, and the percentage is the frequency. So I had 244 sample. It means the 244 was valid and no item has been included. No participant or sample size has been included. Coming towards the reliability statistics, Cronbach Alpha is 0.83, and if you see on standardized item is 0.832. Number of items that I selected was 3. Now if I feel that this Cronbach Alpha is fine, fair enough, I can report it as it is. Otherwise, if I feel that, or if you feel that your reliability is a little less, what you have to do is you need to see this table, item total statistics. Now this will tell you that if you delete item number 1, CPC1, then your reliability, it will increase to 0.864, which was earlier 0.830. And if you delete item number 2, it will decrease, and again it will decrease if you delete item number 3 as well. So we are not going to delete item number 2 or 3. We're just going to check if what it is saying, if you delete item number 1, does it actually increase or not. Let's go for analyze, scale, reliability analysis, shift the item 1 back, select OK. Now it was saying earlier that if you remove item number 1, your reliability would be 0.864, and now as you can see, I have selected only 2 items, item number 2 and 3. It is giving me the exact same value which was suggested by the software earlier. So if you want to delete the item, you can. If you do not want to, that's perfectly fine, because even 0.82 or 0.83 was a good reliability. So what I'm going to do is I'm going to include my third item as well. So this is the reliability 0.830. Now coming towards the second one, you need to go back again, analyze, scale, reliability analysis, shift your all items back. Now put item number 4, 5 and 6 in the items. Now this is not hope. This item, this scale is known as self-efficacy now. As you can see, E, if you go down at the bottom, E means self-efficacy. So let's write self-efficacy. Click OK, and there you go, you have it. You have your reliability for self-efficacy. The reliability is good over here as well, 0.868. If you round off, it becomes 0.87, which is good enough, so you do not have to delete any of the items. Now I'm going to check my other reliability as well for the remaining two subscales. For that, I need item number 7, 8, 9 first. So there you go, 7, 8 and 9. And this subscale is known as resilience. This one, resilience, R1, R2, R3, they are resilience. So let's label it as resilience. There you go, the Cronbach Alpha of resilience is also very good, 0.85 if you round off, otherwise it's 0.846. So I'm fair enough, I'm not going to delete any variable, any item, I'm going to keep them as it is. Now for the last subscale, reliability analysis, again, remove these items, go for item number 10, 11 and 12. And over here, let's see what's the name. It's O. O is optimism. Click OK. And you have your reliability for optimism as well. 0.817. If you round off, it becomes 0.82. Again, I'm not going to delete any of the item because it's just pointless. When my reliability is already good, I will not be deleting it. Now let's check the overall reliability of the scale. Go for analyze, scale, reliability analysis, and include all the items in this box. Label it as psychological capital or whatever the name you have for your scale. Press OK. And for the total, I have 0.94, which is very, very good. So I'm not going to delete any of the items because it's just going to be when I already have a good reliability, there's no need to increase it further. Now, this was for the reliability. For the correlation, what I need to do is I need to sum up all the scales first. And for that, I need to go to and transform compute variable. I need to write the name of the scale. If you double click on it, it will transfer over there. Press sign plus, or otherwise you can just click on this single and shift it over here. Click plus sign, shift this one as well. Now it's hope. The scale name is hope, item number 1, 2 and 3. Press OK. It says it's executed. Let's go and check in the data variable. Yes, hope is there now. Let's go for other variable. Transform compute variable. You have self-efficacy. Now remember, you cannot put space in between, because if you put the space in between, it will consider it as illegal character and your analysis won't run. CPC 4, 5 and 6. Click OK. It says again executed. And yes, we have self-efficacy over here. Transform again, compute variable, reset, item number 7, 8, and 9. Let me check what was the name of this. It was resilience. So let's put resilience over here. Click OK. It's also executed. See, I have another variable now, resilience. I'm going to compute one more subscale, the last one, and it was optimism. Item number 10, 11, and 12. Click OK. Again executed. You have your fourth variable as well, the fourth subscale. Now I need total scores as well. So what I'm going to do is I'm going to go for transform again. Now there are two methods to do it. Either you can do CPC 1 plus 2 plus 3 plus 4, or you can say you can just add all the subscales, because these subscales contain all the variables, all the items only once. So I can do this as well. So it has given me a total score as well. Just change the measure of the variables that you just created to scale. Go back to data view, and now we have to run the correlation. So go for the analyze, correlate, bivariate, go at the bottom, select all the subscales and the total scale, shift them over here. It's already there, the Pearson Product Moment Correlation. This is the complete name for the Pearson correlation. So it's already there, and by default this option is also selected that flag significant correlations. Let's see if we need something from here. Yes, we need to go for the means and standard deviations. Press continue, press OK, and now you have the correlation table. Now let's understand what the correlation table says. Correlation table says is the relationship between hope and self-efficacy is 0.728, which is a positive, because if there is no sign, it means the correlation or the relationship is positive. The lower this thing, 0.00, is the significance level. It's 0.000, which means it's highly significant. If you look over here, it means the relationship between hope and resilience is 0.702, which is again positive and highly significant. Between hope and optimism is 0.642. Again, it's highly significant and it's positive. With the total, the hope with its total scale, that's also positive and that's also significant. For self-efficacy with the resilience, it's again positive, 0.835, and again significant. Self-efficacy with optimism is also positive and significant. Resilience with optimism is also positive and significant. As you can see, the total scale with its dimensions, with its subscales, that's also significant and positively related. Now this means that the variable is generating the correlation with its own. Hope is generating the relationship of 1 with the hope itself. Now this one, the value of 1 is considered as a perfect relationship, which is only achieved when the variable is being associated or compared with the self. Otherwise, as far as I have observed, I have never achieved a perfect correlation of 1. Maybe if you have a different kind of a data when both the values are changing with the same magnitude, that might be possible. But in my life, I have not seen that happen. So let's go for the APA table now. And one more thing before going to the APA table, the values on the left side over 1, they are similar as the values on the right side as 1. If you look 0.728, this is 0.728. This is again hope and self-efficacy and hope. Resilience and hope is 0.702. This also says 0.702. So you need to, in the API, you need to mention only values only on the one side, not on the both sides. Let's go for the API table now. Let me show you correlation table. These are for the alpha values, and you can see, let me just remove these ones for a better understanding. So we have a table over here. We are going to write descriptive statistics of study variable. Then the sample size was 244. So write 244 in all. Number of items, K is the number of items. Is in the total it was 12. In the subscales it was 3. Now we have this will go down over here. And you have to remove all the irrelevant information. So just write O stands for optimism, A stands for hope, SC stands for self-efficacy, and R stands for resilience. Draw a bottom border over here. Let's put all the remaining values so you can have a very clear understanding where the values are coming from. So go to your output. These are the means. For the total, it's 51.13. 51.13. For the optimism, it's 12.76 because you have to take only 2 decimal. We are going to round off. 12.76. For resilience, we have 12.98. In case you have forgotten the criteria of rounding off the values, you need to see where you're rounding it off. For the APA, it says only 2 digits after the decimal. So you have to see if the third digit, this one, if it's at 5 or above 5, you're going to add 1 in the second digit. If it's below 4, then you're just going to remove the values from after the 2 digits and you're going to write this as it is. So it's 12.72 for self-efficacy. No, it's 12.73. I needed to round off. For the hope, it's 12.67. 12.67. Let's go for the standard deviation. For the R, it's 4.10. For self-efficacy, it's 3.83. For hope, it's, I think I made some mistakes over here. Let's correct them. CPC for the optimism. For the optimism, yes, it's fine. For resilience, no, it's not fine. This value was supposed to go there and hope was supposed to come down. Self-efficacy is 12.73. Yes, now it's good. So I was here. 4.10 was for hope. 4.10 is for hope. For self-efficacy, it's 3.83. Yes. For resilience, it's 3.72. And for optimism, I have 3.74. For the total, I have 13.81. Let's remove the values for now. The alpha value, this is alpha sign, the reliability sign. Go over there, check your reliability. For the total, it was 0.94. For the optimism, it was 0.82. 0.82 for optimism. Scroll further and you have 0.85 for resilience. And you have 0.87 for self-efficacy. 0.87 for self-efficacy. And you have 0.83 for hope. So it's 0.83 for hope. Now these are the potential and actual ranges. Potential ranges is that you have to, if you see this scale over here, this is general criteria that you have to score between 1 and 6. For the potential, what you need to do is you need to multiply the number of items with the minimum value first, which is 1, and then multiply again the number of items with the maximum score that a person get or a person can get. So it's 12 into now 12 into 6 is 72. For this, you are going to write 3 in till 18, because 3 multiplied by 1 is 3, and then 3 into 6 is 18. So I'm going to repeat the potential ranges for the further subscales as it is 318, because the number of items are the same, the scoring criteria is also same. Now this actual means what range you have achieved in your data. So I have to go back over here in my SPSS and I need to go analyze descriptives. Shift the variables. I need range or the minimum maximum, but this will also do the minimum and maximum. Press continue. Okay, and you have your minimum and maximum. Now these are the values that have been achieved in the data. They might be different, they might be same. So let's write in our table over here. That was the output. So it's 318 for all the subscales is the same. So I'm going to repeat the values in the actual ranges, and for the total it's 13 till 72. So I need to write 13 till 72. That's what any participant or an individual got in my data. This is a bit different from the potentials. It can be different. You do not have to worry about it. Now coming towards the correlation, let's generate the table of correlation over here. to the insert table. This will do. So write the title of the table. Either you can write all the name of subscales, hope, resilience, self-efficacy, optimism, and psychological capital. Or there is another way to say that correlation of psychological capital and its subscales. You need to write the variable over here. This should not be bold. You need to write the mean and standard deviations. You can generate your variables over here. So if there's no space, go for the insert rows below and just add it. We have for the correlation, we have hope, self-efficacy, resilience, optimism, and the total. So we are going to write hope, resilience, self-efficacy, optimism, and CPC total or psychological capital. Write the mean and standard deviation from here. So I've already put it over above, but I'm only going to copy and paste them. In order to not or just let's write it from the output. For hope it's 12.67. For resilience it's 12.98. For self-efficacy it's 12.73. For optimism it is 12.76. For psychological capital it is 51.13. Standard deviation, write the values as it is, 4.10, 3.83. For resilience it is 3.72. For optimism it is 3.74. And for the total 13.81. Now what you can do is select them and put the bullet forms over here. If the number is not correct, just restart it at 1. So 1, 2, 3, 4, and 5. And over here you need to write 1, 2, generate the more columns over here, columns to the right, one more, and one more, columns to the right. So it's 3, 4, and 5. In the diagonal, I'm going to put dash because instead of 1, we use dash. And over here, I can write the values. So see where you want to write the values, either on the right side of the diagonal or the left side of the diagonal, depending where you are submitting your article. Right now we can write on the right side, that's not the issue. Only the thing is the sample size should go at the bottom over here in the notes section. For this, its hope and self-efficacy is point, or let me just interchange them because it's confusing me a bit as well. There you go. Self-efficacy, hope, self-efficacy, resilience, optimism. So now we are perfectly fine. 0.73, 0.70, 0.64, and 0.86, 0.91, 0.93, 0.86, no, 0.89. For these three values, 0.84 and 0.72, 0.84 and 0.72. The last one is 0.83 between resilience and optimism, 0.83. So select your table, go for the borders, remove all the borders, no border, and then bottom and the top one. Select this one and activate bottom border. And for the table or for these values, they could be centrally aligned as well. Note n is 244. This should be in simple plane like this one. Now we have to use the statics. Over here we have only 0.00, so we are going to use 3 statics with all the values, and we are going to write that what this 3 static means. It means the p-value is less than 0.001. We have to use 3 static with all the values. If you feel the statics are a bit larger, what you can do is you can select the static and go over here and superscript them. So they will become smaller, just like the power. Because sometimes the table is too big to be handled on a single page. So this function will come in handy. And in the interpretation section, you can write that Pearson Product Moment Correlation analysis was run between all the subscales of psychological capital. The results show that there is a positive correlation between hope and self-efficacy. In the bracket, you need to write the value of R, which is the correlation 0.73, and the p-value as it is 0.000 or less than 0.001. Now, this is for the single value because in correlation, a single value only gives you the idea, the relationship between two variables only. So you need to write interpretation about all the remaining values, about all the remaining variables. And if the sign, there is no sign, it means the relationship is positive. If there is a negative sign, then the relationship is negative. Done the correlation on a simple analysis, But let's just say, what if you want the correlation for different groups? For example, gender or marital status. In gender, you might be having two or more than two categories, like male, female, others, not specified, trans. So what would you do? How would you calculate your correlation based on the group that you want the specific? I mean, maybe I want to just see the correlation for the males only, not for the female, not for the combined data. What would I do? It's a very simple thing. All you have to do is you have to go for the data, go to the split file, organize your outputs by groups, and select the IV or the category that you want. It should be there. For example, I want to split my file by the gender, so click OK. Now, as you can see, my output is going to be sorted by cases by the gender, and the split file is on now. So all I have to do is I have to go for the analyze, correlation, bivariate, put whatever you want. Let's go for 4 or 5 or simple things. So we have an idea what the output is and how to interpret the output. Now, this correlation table is for the males, and this one is for the female. Since it's giving you two different tables for male and for female, it's also telling you about the sample size. For male, the sample size is 144, and for female, the sample size is 135. But in the APA, you have to combine both these tables, and this can be combined like this. Let me zoom in for you. So as you can see, this is a table, correlation table. These are the diagonals where one is supposed to come, and while you're putting the values, you need to specify that coefficients below the diagonal represent correlations of male or female, whatever you have put. So basically, these values, the values on the left side or below the diagonal, they are the correlation of males, and above the diagonal or on the right side, they are the values of female. So this is one thing that I wanted to show you. I hope that you have understood. Once again, what you need to do is go for the analyze or go for the split file, and for the split file you can have your output sorted by the cases, sorted by the different groups. This is the same interpretation that you use in the correlation, so you don't have to worry about it. Since the variables are more, the output is more. All you have to do is just create the output, write the interpretation as per your variables, as per your output, just repeating the criteria, just repeating the procedure. You have to go for the data, split file, shift the variable, click over here, shift the variable that you want to be sorted, click OK, it will be done. To turn off the split file, all you need to do is click on this one, analyze all cases, do not create any groups. Click OK. Now the split file is off. Now once you run, just to check that are they actually off, once you run the correlation, it's going to give you a single table not specified as the correlation is for male or for the female. See, the split file is off now. Now you can run your analysis as per the simple criteria. That would be all. Thank you.